All right. I think before I started, I have a quick disclaimer to share. I've tried 49 times to record that video, so that wasn't my first time, so I think the end result would that matter, right? Thank you for everybody for coming here. Let me ask you this. How many of you are truly enjoying this big data conference so far? Raise your hands. That's so cool, right? I'm learning a lot with this conference. Thank you for the organizers for inviting me. I think it's been really productive to me to not only meet Vilnius because it's my first time here, but also to understand a little bit of your culture and, more importantly, share and understand something from you as well, right? This presentation, where obviously the title I stole from that old movie, for Woody Allen movie, not sure how many of you have watched it, Everything You Would Like to Know About Sex. I just replaced it, sex, with Apache Kafka, right? But the intention would be the same, which is clarify a little bit about whatever understanding you might have about Kafka. And for those of you that may think that Kafka is purely a messaging technology, that session is going to be really interesting for you, right? And for everybody else that never heard about Kafka, I think it's going to be very interesting as well, because I'm going to explain what Kafka is, all right? First of all, I think I have more than introduction so far. So my name is Ricardo, right? I currently live in North Carolina in the United States, and basically I work for this company called Confluent, right? Confluent is a startup from California. It has been founded by original creators of Kafka, so that's why we are so intimately, directly involved with the technology Kafka. But more importantly than actually develop the open source project, Confluent builds event streaming platforms on top of Kafka. So that's what I'm going to try to show you here today, all right? At Confluent, I work for the developer relations team. So essentially, I am a developer advocate. My job is, I like to explain that my job is to teach, essentially. So teach what Kafka is, what you can do with Kafka, what you cannot do with Kafka. And my primary audience are developers, data engineers, data analysts, big data engineers, and everybody that deals with data, right? Those are my contacts. If you care to maybe have some follow-up questions with me, like this is my email, very easy to understand, ricardo@confluent.io. My social networks are pervasive. I've made the effort to make all the handles to be the same on LinkedIn or on Twitter or GitHub. The code that I'm going to show here today is already on GitHub, so go there, grab it, use it, do whatever you want, have fun, all right? So, if I ask you right now, how many of you know what Kafka is? Let me know. I'm probably going to have a hard time to see the hands held high because of the lights are straight out of my face, but keep your hands high. How many of you know Kafka here? Know in a sense of, yeah, I have heard of, or I have worked it before, or I am working actively with Kafka. Good. So I would say that 80% of the room knows Kafka, which is good. Okay? Now, what is a distributed streaming platform? How many of you know what that is? Yes, that's what usually what I expect, because usually people know Kafka, but they don't know what a distributed streaming platform is. So if you go straight to the Kafka website, if you do this right now, you're going to see that right below the logo of Kafka has this, Kafka is a distributed streaming platform, right? So right off the bat, the website is explaining to you what to expect about Kafka, right? And before I move on with this slide, let me give you probably the most important tip that I could share in this conference with you about Kafka. The logo of Kafka is a letter K. This means a K, all right? So this is important because whenever you get a sticker of Kafka, never put on horizontal, because if you do this, it won't be a K anymore, all right? K stands for Kafka, right? So when you start talking about distributed streaming platform, usually that's the face that people do about, what the heck is this? I've never heard about this term before. What kind of problems can I solve with this technology? So distributed streaming platforms, conceptually, it's something that technology speaking, has been around for more than 10 years. There are technologies out there that works and behave as a distributed streaming platform, but the industry itself has been kind of a very eager to understand a little bit more for the last 5 years. So there's a lot of ground to work with, and that's what we at Confluent we're trying to do. And there's no better way to understand what the distributed streaming platform is other than in understanding what streams are, right? I was kind of 2 weeks ago in a conference for Microsoft Ignite in Orlando, and we had a booth there where lots of developers was passing by and asking, hey, what do you guys do? So I've told them, we build event streaming platforms. So, oh, streaming, yeah, I know this. I have Netflix at home, so yeah, it's cool, right? So, yeah, not that type of streaming. That's a different type of streaming, but if you care with me, I can explain better. So, for those of you that never fully understood the concept of streams, I would like to invite you now to make an experiment, a fun one, right? Which is basically play Pac-Man, right? Come on, who doesn't love Pac-Man? So grab your phones or tablets or whatever you have there, scan this barcode, and what I want you to do for the next 1 minute and a half is play Pac-Man, right? That's your part. My part is explain what streams are. Your part is play Pac-Man for now. And just let me know when I can flip the screen to show something. When the application opens up, you're gonna be asked to provide your name or your nickname or whatever you're gonna be calling, right? And you press enter or play. There will be an animation which is going to present the ghosts of Pac-Man, and each one of them will have some Kafka nicknames like partitions, offsets, and brokers, and things that are typical in a Kafka word. And then if you click with your finger, you're going to start playing, all right? Are you guys playing already? I can actually check that by showing you what streams are. Keep playing for now. Yep, I think there's a lot of people playing. And for whoever from you never saw a stream in your life, this is a stream, right? So let's define what a stream is. A stream, it's something that never ends. It's an unbounded set of events that doesn't have an end. It never stops. It's infinite, right? And that, conceptually speaking, is where we start introducing a lot of challenging in the way we handle data these days. Because if we go back 10 years ago, 20 years ago, or 30 years ago, we were dealing with technologies such as databases and Hadoop and things like that, where all the data sets were finite, right? You would load them up, eventually you would stop, and from that part of the data set that you have acquired or installed in a database, you would start processing, right? So there was a clear separation of, I'm going to gather the data, I'm going to store it, and then I'm going to process. But how do you do the same thing with things that never stops? Have you think about this? So that's the challenge that we will be discussing for the last 20 minutes, and then I'm going to dig deeper into how Apache Kafka handles this problem, all right? But for now, let's just stick with the fact that what a streams is. Can you repeat back to me? Come on, read out loud. Streams are unbounded sets of events. All right? So let's keep this in our mind for a second so we can understand that, like I told you before, the current set of technology that we have these days, right, are not fully appropriated to handle that type of workload, all right? And let me make a quick pause before I continue. The objective of this presentation, it's not saying that from that point on, everything you have to do will have to be based on streams. I am not saying that. I still believe that finite data sets, workloads, typical that you deal with big data. Pictures are always nice. So workloads that you typically deal with big data will still exist. I mean, Hadoop is not dead, right? Hadoop is a technology that will probably be alive for the next 5 or 10 years. But what I'm saying, and what Confluent has been seeing for the last 5 years, is that the applications that we are dealing these days are requiring that we no longer have to wait until data is stored until we can start processing it. That's the paradigm shift that we are observing, all right? So, in order to fully understand this, let's go back in time so we can kind of make a reflection about what is the current state of the technology that we have these days. And by the way, for those of you that never watched Avengers Endgame, I'm sorry for the spoiler, because this is how the Avengers beat Thanos, all right? But the movie has been kind of released like months ago, so that's how I kind of, I'm okay in releasing the spoiler right now, okay? So, 30 years ago, databases. How many of you know databases here? No matter what they are, databases are good, works, right? 30 years ago, databases used to be like this. They would be that bulletproof technology that you would use for solve any kind of technological problem, right? 2019, databases are not that good anymore, all right? And bear with me, I am not saying that databases are not important anymore. It's a different kind of a perspective. What I am saying is that you no longer solve all the problems of the world simply using databases, all right? There are problems that we have to deal these days that databases alone, we won't be enough. That's what I'm saying. Databases as a technologies are amazing, no matter what databases is, all right? So, what type of problems we see that databases kind of have? Two of them. First of all, I think Confluent thinks, probably everybody thinks as well, that databases are limited, all right? And they make a lot of mess. I'm going to explain this why, right? For those of you that are database developers or DBA, please don't hate me, okay? What I'm trying to make you understand is that because those technologies has limitations, other technology has been created, right? I'm just creating a mindset. Individually, databases are still important, just like I told you before. So, why is limited, if you think about it, right? Before I actually explain, how many of you think that databases are limited? Raise your hands. Interesting. 50% of the room. All right, we're going to have some debates here, probably. So, in my opinion, databases are limited because if it wasn't for the fact that it is limited, you should be able to process analytics on top of your database transactions. All right? But what we do today, what we have been doing for the last 30 years is, yes, we have this whole databases that are dedicated for the transactional workload, right? We usually use them for the business hours, and then we have to, like, outside the business hours, you know those midnight batch workloads that basically load up the data from the transactional databases, from the data warehouses or data lakes, so the data analysts can actually start doing some analytics. If it wasn't for the fact that databases are limited, that would not happen, right? And because that happened, we create what we call the mess, right? Why we call mess? Because how many of you sympathize with this diagram? Like, Like how many of you can say, yeah, this is the story of my life? Look into this diagram right here. Pretty much everybody, right? It was part of my life for several years before, right? And this is no shame, because this is a problem of the technology. The technology kind of created that problem, right? We at Confluent, we have this concept of incidental databases, right? What are incidental databases? Incidental databases are those databases that conceptually should not exist, all right? For example, you have the transactional databases, right? Where all the transactions from your applications are going on, and you have your data warehouse, or your data lakes, or whatever database that is dedicated for analytics, right? And in between those databases, you would have lots of staging databases, or conciliation databases, or migration purposes databases, where the only focus of those databases is grab the data from the transactional, perform some sort of a ETL, extract, transform, load, right? Shape the data, consolidate the data, make sure the data is ready to be used, perhaps do some data curation, which is make sure the data that is missing is no longer missing, until the data is actually delivered to the other end, which is for doing the analytics. And let's face it, what is more important here? What type of databases actually need to exist here? The transactions ones, of course, and the analytics ones. Those databases, they should exist. They have a meaning, they have a purpose. But the ones in the middle, those are incidental databases, and that's the ones that creates this mess. All right? That's why architectures, data architectures these days are so damn complicated. All right? Again, all started because databases has a limitation. Okay? In the last 30 years, remember we came back 30 years in time, in the last 30 years we have observed some workarounds that the industry kind of created. I think the most important workaround that we created was big data. Hey, we are in the big data conference, right? So that's the best place to discuss big data as a workaround. So I'm going to ask you before explaining, what type of fundamental problem big data solves? What problem? I like your answer, horizontal scalability, but volume, right? The problem of volume, right? If you ask any database, no matter what database technology they are using, if you start asking questions about, hey, can I use this database to store like 5 petabytes of data, and probably on the last 3 months, it's going to increase like 1 petabyte per month, what the DBA is going to tell you? No way. It's not going to keep up. It's going to slow down the database. So for those type of workloads are more appropriate to move out for things like big data, for things like Hadoop, right? That has been designed, like he said, thank you, it can deal with the problem of volume using horizontal scalability, right? What HDFS does, essentially, basically distributes all the data across multiple data nodes, right, where you can form a conceptual storage that is the sum of all the storage nodes, right? So, pretty cool, right? However, it doesn't solve the fundamental problem of, okay, I have the data, I storage, I have huge amounts of data that I can deal with, but how can I process, right? And that's one of the problems that not we, Confluent, but we, the industry, observed about Hadoop and big data technologies. It became so damn complex to actually start dealing with this processing part of the data, right? Hadoop itself does an amazing job to ingest the data and store. All right, good, perfect, no doubt on that. But storing data is only half of the story. You have to still process it. And by the time you have to start processing the data, that's where the complexity is. And we usually have those kind of unicorn developers that those are the ones that honestly would have to know all those technology stacks from the big data ecosystem in order to do something useful with the technology, right? So that's a problem. It's still that instigates the problem of mess, okay? Not to mention that's still kind of a very troublesome to hire this kind of people right these days, right? NoSQL, that's another workaround. NoSQL are beautiful technologies, all right? I'm a big fan of NoSQL. I have worked with some of them that I've listed here, MongoDB, Cassandra, Elasticsearch. Amazing technologies. Just like big data, they have been designed to deal with huge amounts of data and doing sharding or partitioning or spread the data over multiple nodes in the network to handle the volume. But still, it doesn't solve the problem of processing. You gather the data, step number one. You store the data, step number two. And then somehow, someone, eventually, have to process. So you see that we have been creating these technologies as workarounds, but we are not solving the fundamental problem, which is, bear with me right now, the fundamental problem we are talking here is to minimize the window. Look at this. To minimize the window when the data is acquired, by the time the data is effectively processed, right? So in other words, I'm not talking about no longer have 24-hour batch windows for having a result. I'm talking about no longer have a week or a month or 3 months of period until we have some data that is useful to take actions upon. All right? Instant decisions, instant data. That's what the industry is doing these days. Take, for example, Uber. What Uber does best, it's correlate positions of your driver and your passengers and correlates a lot of other information regarding, for example, the traffic and gives you in near real time the information for how long the driver is going to pass by where your location, all right? It could not possibly be implemented using technology like this. It has to be instant data, all right? So that's what the changing that we are observing, all right? Messaging technologies are great. I would say that I've dedicated myself like more than a decade of my career working with this. Before joining Confluent, I was working for Oracle, where I joined originally on BEA, and I was basically writing the code for WebLogic JMS, right? So I know a lot about this stuff. But if there's one thing that I've learned about messaging is this. Messaging is all about grab data from point A and deliver to point B. That's it. Can you agree on that? What happens with the data when the very last consumer of the data that is interested on the message receives that data? What happens with the data in the messaging technology? Explodes, disappears. Because messaging was not designed to retain data. Messaging was designed to deliver data reliably, consistently, but yet just to deliver data, all right? So, what is the result of all those workarounds that has been created for the last 30 years is that we still have the same mess, but in my opinion, is a bit more colorful if you think about it, because there's some pretty cool technology that we have these days, like Cassandra and Elasticsearch. So the diagram looks like better, right? But this is still a mess, okay? So there's still a problem in the table that needs to be solved, okay? And let me give you a little bit of a spoiler here. How many of you know Apache Kafka, as I told you before, right? Probably everybody. So Apache Kafka has been created originally on LinkedIn, thank you, on LinkedIn, right? Plus, I think it's 11 years ago, I think. Probably a little bit more than that, but let's stick with 11 years for now. And on LinkedIn, basically the problem that those two guys and the lady were tackling with was ensuring how to minimize that mess that they were creating. So let me give you a glimpse about what was their approach to solve that problem. First of all, this was the first design of LinkedIn, by the way. So not many different for any web architecture that you would develop as a developer, right? There is a central database where all the applications would read and write data, right, consistently. So cool. But they realized that because of the use case of LinkedIn, they would be more interested in events rather than state. right? And what is the fundamental difference between events and state? Events has context. Events has meaning. Events answer many more questions than simply state. Databases are good to store state, right? For example, when I left Oracle and I joined Confluent 1 year ago, there was a reason why I did this. There was a circumstance why I did this. There was a context why I did this. And all of this is captured in an event. But by the time you grab the event and simply store it in the database, the only thing that the database can answer you is, I work at Confluent. I work at Confluent. I work at Confluent. You've lost the context, all right? So the number of questions that you can answer with this minimizes considerably. And when you design your systems based on events rather than state, you can actually have much more sophisticated system, which is, instead of the system actually have, this is how we design for databases, right? The system goes to the database, asks the question, asks the data, and then goes back and start using it, right? This is how we design oriented to databases these days. But the ideal world is that your applications or microservices should be actually subscribed to the set of data they are interested, right? And by the time those events happen, they are pushed into the application. So the applications can actually react immediately and start doing some processing with it, right? And that diagram right here, though is really simple, has a very important concept that probably Larry Ellison from Oracle or any other creators for the major databases in the world are probably crying when they see this diagram, which is, do you know how Apache Kafka solves the problem of streaming beautifully and scalably the way it does? It's because Apache Kafka is all about this. It's a log. It's how Apache Kafka structures the data, right? And why I told you that Larry Ellison might be like crying and other database creators are crying, because any database in the world underneath has a log. Did you know this? Any database, Oracle, SQL Server, Postgres, MySQL, DB2, Informix, Cassandra, MongoDB, all databases underneath has a log. But someone right back in the 70s, they had this idea that, no, logs are a very complex abstraction that we would expose to developers. Let's expose them something simpler called tables, right? And when they did that, they gave up of all the beauty of scalability and dealing with events, all right? So, pretty much, LinkedIn realized that they were dealing more with the events than data, transactional data, as they call it, right? So they realized that databases itself wouldn't be enough or a very good solution for us. So their realization was, we have to actually use the log of a database. Not the database itself, but the log, all right? And that log they created eventually became Apache Kafka, all right? When you design your systems based on logs, and by the way, why they are not using messaging? Because messaging has no persistency, as I told you before, and it also has scalability limits, right? When I mention scalability limits, what I'm trying to say is messaging technologies, it makes a difference if you are dealing with 5 consumers, 5,000 consumers, or 5 million of consumers. By the time you increase the number of consumers, your messaging technology, your messaging technology is going to start to slow down, just like databases, right? So they're not very good in dealing with volumes, but Kafka is, right? Because Kafka structures the data using the concept of logs, right? So let's make a quick wrap up here. We're 10 minutes away, right? See, I'm counting with you. We're 10 minutes away from the end of the presentation, and that is the most important slide, other than the explaining of the Kafka logo in the beginning, that I would like to share with you. If we look and compare, if we contrast and compare the ETL and data integration space, which has benefits, of course, it's highly scalable, it's durable, it's persistent, it's ordered, but has problems, right? It's batch, it's expensive, right? It's time consuming because The rated will only be available hours later or weeks later, because otherwise we will not offload the transactional databases. And messaging has a lot of problems as well. It has a problem to scalability, has no persistency, has a problem of consumption, and has no replayability. Replayability is, what I mean by this is, let me give you an example. Imagine that you are dealing with database and you are building a batch ETL, right? And the purpose of this batch ETL is to build up a consolidation system, right? So in this consolidation system, after you process all the data, which is transactions, money, right? You should end up with 10,000 euros, for example. That's what will be your expected result and outcome. But by the time you process all the transactions, you would end up with 9,700 euros, right? So there's definitely a problem on the conciliation project. So where the heck end up the last 300 euros? What can you do with ETL and databases? You can reprocess them, right? You can just change a few queries, but you have the ability to reprocess them because ultimately the data is in the database, right? It's persistent. Messaging cannot do this, all right? Because there's no persistence. So, remember in the beginning that I've told you that we're talking about what here? Besides Apache Kafka, what kind of a concept we're talking here? Start with distributed streaming platform. A distributed streaming platform is the best things of both worlds. That's the best way to describe what a distributed streaming platform is, all right? You grab everything good about messaging. You grab everything good about database technologies. And you take aside all the problems of the scalability, right? And you would end up with a distributed streaming platform, or, in other words, Apache Kafka, okay? And for those of you that maybe are wondering, scalability problems, there's a very unobjective word. LinkedIn uses Apache Kafka for pretty much everything these days. And the words keeps changing, but I think the last what I've heard is that on a daily basis, they basically process 3.8 trillion of events per day, and they come up with more than 4 petabytes of data per day. And all of this is passing through, you know what? It's passing through this over here. This log. So what I'm trying to say is scalability for Kafka is not a problem, all right? The problem is when you have to start thinking your systems based on log and events, and that's that's the way we design systems these days, right? Some people ask, why we never kind of explain Kafka or distributed streaming platform this way? Because everybody kept themselves focusing on thinking that Kafka is just messaging. That's the problem, right? Kafka is not just messaging. Kafka is a log, all right? And matter of fact, Kafka has been based on this paper about this guy called Pat Hanlon, very good. He wrote this paper about how to solve fault tolerance and scalability problems using distributed systems and the concept of logs. And logs are very simple abstractions. It's basically the data is structured one after the other. So the new data always goes to the tail of the log, right? And multiple applications can read any information, right, in a given point in time, right, without creating bottlenecks for the other applications, right? I like to explain the concept of log with this mem, right, where the pointer of whatever application is reading is the offset. We call offsets in Kafka, right? So in one point in time is reading for one record, and another point in time is reading for another record, right? And the ladies in the room, don't be upset because mans can be records as well. So we have to be respectful with the ladies as well, okay? So we have about 4 minutes and 13 seconds, roughly, right? And I would like to invite you again to play Pac-Man. Just start playing Pac-Man again, and I'm going to do some fun here, which is compute in real time your scores. So you can see that whatever I'm talking here is actually working. Scoreboard? Yeah, scoreboard. Oh, my battery is 19 minutes. I forgot to put my chart in. I think we'll be good. Okay. So this, if I ask for anyone that have worked before with a database technology, right, they would say, I know this. I've worked with this for the last 20 years. This is a table, Ricardo. Yes, this isn't a table, just like you would have with Oracle, Postgres, or Cassandra, or MongoDB. But there's one difference. And I want some of you to tell me what the difference is. What's the difference from this table to any other database table? It's a streaming table. And in other words, it's alive. It's alive. It's live data that doesn't have to wait until the batch process runs on midnight to bring the data so you can start acting upon the data, right? That's the future of, we believe, that's the computing of data today, right? As I told you before, not all use cases actually will benefit for stream processing, right? But I'm pretty sure you can see some of the, look at this, I don't know who that is. But I'm pretty sure that you can see some value on doing things in real time, right? So with that, I think we have 2 minutes, probably. I'm good at counting, see? Like we're on the same page. That's what I have for you today, so we can use this 2 minutes maybe for a Q&A.
Yes, we can do. Do we have any live questions from audience?